racks are highly efficient structures that require their components to be damage-free. The only thing that engineers look to do and OEMs for racking look to do is to make something that could hold a certain load under various conditions as cheaply as possible, right? So that's why you'll see various designs that perform extremely well, but they have to perform without being damaged. Once we introduce damage, whether it's bent brace, whether it's an impact to the front or back column, or even to a beam, we're now introducing a variable that was not considered necessarily as that racking was designed. So here we have some examples of damage that I'm sure folks can attest to. So starting from, you're an end of an aisle, someone makes a tight turn and clips the upright, or sometimes we're stacking materials at the back end of an aisle, which causes damage to the upright, which now we have to contend with. Same thing for the middle here. We're not even making contact with the slab anymore. So that upright is supported only by the back leg and the other uprights surrounding it. That's the only reason why this thing hasn't toppled yet, because as you can see in the image, it's still being loaded. And then to the far right, we have a structural upright in a drive-in situation with the pallet barely hanging off the rail due to the deformation on that front column. So with the top pallet, as you can see, almost ready to fall. So this is a catastrophe in weighting and things that we want to be mindful of, because if we don't take action, if we don't do the things that we're going to be talking about today, these are the unfortunate remnants of what could happen. So we never like to scare folks into doing the right thing, but I think images like these, I think, drive home the idea that if damage to an upright, if left unattended, certainly the tragic consequence could be a collapse and, of course, fatalities.